Good day. My name is Dale Prasad, and today I am going to present the work which was done by my group for their electromagnetic field theory group project. The objective of our project was to determine the performance difference between two types of Rogowski coils. A Rogowski coil is a passive transducer which is used for current sensing. A conductor with an alternating current, when threaded through the Rogowski coil, will induce an electromotive force in accordance to Faraday's law. The electromotive force induced in the Rogowski coil is proportional to the rate of change of current through the conductor and its frequency. The characteristic non-ferromagnetic core of the Rogowski coil results in its low inductance. As a result, the Rogowski coil's current response is linear, immune to saturation, and fast responding. Two different types of Rogowski coil were investigated: a circular Rogowski coil and a diamond-shaped Rogowski coil. The magnitudes of the voltages induced in both types of coils were investigated when a current-carrying conductor was threaded through the Rogowski coil's loop. The first simulation is shown here. This is the circular Rogowski coil. A toroid was used to represent the Rogowski coil, whilst a cylinder was used to represent the current-carrying conductor. The air boundary was represented using a sphere. Materials were then assigned to the Rogowski coil. Air was assigned to the sphere, whilst copper was assigned to the Rogowski coil and current-carrying conductor. The magnetic field study was selected to simulate the Rogowski coil, since the principle of its operation is based on Faraday's and Ampere's law. A lump port was used to set up a current in the conductor. The type of port selected was coaxial, whilst a current of 5 amps was set through the conductor. A multi-turn coil was then used to assign the coil type and number of turns, whilst reference edge was used to stipulate the direction of each turn. Varying mesh sizes were chosen. Since our analysis focused mainly on the Rogowski coil, everything but this geometry had a coarse mesh. The study selected was current coil calculation, which was required to determine the parameters of the Rogowski coil. Frequency domain was used to set up a frequency of 60 Hz. This should enable the lump port current to be an AC at 60 Hz. The results for the study are as follows. The voltage induced in the coil is. Moving on to the second Rogowski coil design, which was investigated. This is the diamond-shaped Rogowski coil. This coil was drawn in SolidWorks and imported to COMSOL via the Live Link interface. However, due to minor incompatibilities with both softwares, scaling and rotating were required. The geometry of the current-carrying conductor and air boundary remained the same as the first study. The same materials were assigned: air to the spherical boundary, copper to the central conductor and Rogowski coil. Magnetic field study was again selected. The lump port was set up exactly as the previous model, whilst the multi-turn coil was set up with exactly the same turns and the same coil direction. A variable mesh was again used, where the Rogowski coil was subjected to the finest mesh. Finally, the results are as follows. The voltage induced in the coil is, whilst the direction of the magnetic fields is. Thank you all for watching. I hope this was informative.